Hi everybody, very warm welcome to Vedantu JEE English channel, and like I always say, hello guys. Yes, very good evening. Alright, so in today's session we are going to complete two chapters, that is electrochemistry and chemical kinetics. Basically we are going to cover the most important formulas and then we will be solving some questions, okay? But before that, like I always say, Andariki Namaskaram, Ellargu Swagatam, and a very warm Vanakkam to Vedantu JEE English channel. This is me, your master teacher Nabamita Ma'am, and today we are going to complete two chapters. So yes, I know I'm looking very energetic, but believe me, I am not at all. Still in a lot of pain. Still in a lot of pain. Anyway, so guys, without much further ado, let us start with the session. And yes, I'm not going to talk to you guys because this is basically like a last lap before your second attempt of JEE. Plus, you will also be sitting for your board examination very soon. So I'm not going to talk to you just so that I can save a little bit of time, save my throat. My throat is still paining. I'm going to talk a little less and I'll talk only the things that are related to the chapter. Apart from that, I will be talking to you very soon after the session is over, and after I'm feeling a little better and you guys are done with your exam. But right now, I believe that it is the need of the hour to not talk to you guys and start with the session. All right. Yes. So I hope that no complaints and you will understand and you will forgive me because really my throat is paining a lot. So I'll stick to the important part of the session. Okay. Now let us start with electrochemistry, guys. And in electrochemistry, what is electrochemistry? Electrochemistry is such a chapter where we study about electricity and how that relates to chemical reaction. So when we're talking about electricity and we're talking about chemical reaction, that means we understand that here basically a chemical energy is going to get changed to electrical energy. Now that will be the spontaneous reaction, because chemical energy, there is some chemical energy and that is getting converted to electrical energy. But there is also the non-spontaneous part where we have to give in some electrical energy for a chemical energy to happen, right? That is possible, okay? Now I have just spoken to you about spontaneous and non-spontaneous. So what is spontaneous part? What is spontaneous reaction? Spontaneous reactions are basically those reactions which are capable of proceeding in a given direction without any external energy being applied to them, right? For example, a chemical reaction happened, from there some sort of energy came out, and that energy directly is getting converted into electrical energy. So that is a spontaneous reaction, right? You didn't have to do anything, exactly. But in case of non-spontaneous energy, what happens is it requires an external energy to proceed. What does it require? It requires an external energy to proceed, okay? So for electrical energy, you have to provide electrical energy first, then the chemical reaction will happen, then the chemical energy will come out, right? Okay. Now, in this chapter, we do talk a lot about batteries, okay? We do talk a lot about cells. So when we talk about cells, there are two types of cells we talk about. There is one that is electrochemical cell and the other one is electrolytic cell. What is electrochemical cell? Electrochemical cells are, galvanic cell, voltaic cell. They are all electrochemical cell, right? So in an electrochemical cell, what happens is the chemical energy is converted to electrical energy. Basically, the spontaneous reactions are happening there. And in case of an electrolytic cell, electrical energy is converted to chemical energy. All right, everybody. Okay. And yes, once again, in this particular chapter also, we do talk a lot about oxidation, reduction, oxidation, reduction, right? So you still have to remember that red cat and anox thing, that is the reduction happens at cathode, and at anode you get oxidation, isn't it? Yes, we do that. Now, first of all, we come across the Daniell cell. Okay, we will come to cell potential and I will show you all the important formulas, don't worry. It was designed by someone named as, what was the name? John Daniell. John Daniell designed it. What he did was he took two containers, one where zinc rod was there and in the other one there was copper rod, right? So basically he took two containers like this. He took two containers like this, yes, one where this, imagine this is copper because copper sulfate is blue, so copper, and this is zinc rod, right? Now zinc is dipped in ZnSO4 solution and copper is dipped in copper sulfate solution. Now what is happening? What is happening is, you see after some time, what is happening is, the zinc, what it is doing is, yes, it is getting, okay, let me tell you first, okay, so there is copper here, yes, this copper here it is grabbing hold of electrons which the zinc has just lost. Zinc has lost 2 electrons here. Zinc has lost 2 electrons. These electrons now are getting into the rod and they pass through the wire that is connecting these 2 electrodes. And here all the electrons that are getting accumulated, the copper sulfate in the solution, this copper is going to grab hold of these 2 electrons and it is going to get converted to copper, solid copper. So the electrons will flow from anode to cathode, but electric current flows opposite, that is cathode to anode it will flow. Okay. Alright. So what was happening was the zinc 2 plus, Zn2 plus was getting accumulated in the solution. SO4 2 minus was also getting accumulated in the solution. The electron flow at certain point will stop. Why? Because there is too much positive ion. And obviously electron being negative, it will want to get attracted towards the Zn2 plus, isn't it? But who will neutralize, Baba? Who will neutralize? Somebody has to neutralize, right? And that's when we introduce the concept of salt bridge. Okay. So what does the salt bridge do? The salt bridge can do 2 or 3 stuffs. Okay. The salt bridge can do 2 or 3 stuffs. So let me tell you what are the importance of salt bridge. Number one is that it maintains electrical neutrality. Okay. Salt bridge, what does it do? The first thing that it does is it maintains electrical neutrality. Alright, maintains electrical neutrality, everybody. Alright, secondly what it does is, in each of the half cells, by the way, yes, completes the circuit. Completes the circuit, okay. Secondly, reduces junction potential. Thirdly, sorry, reduces junction potential. Alright, so basically these are the things that the salt bridge can do, okay. These are the things that a salt bridge can do. Alright, everybody, yes. Now this is all the things that we have read about a cell and the salt bridge, and this was just the introduction part, my dear student. Okay, now we come across something that is called as standard electrode potential. But before that, let us understand what is the cell potential. How do you write the cell potential, guys? The cell potential can be written as E naught cell is equal to reduction potential of the cathode minus reduction potential of anode. Okay, all right, everybody, yes. Now what is standard electrode potential? Before that, let us understand what is electrode potential. Electrode potential, my dear student, is the potential difference that is developed between the electrode and the electrolyte, just like how we just saw in the Daniell cell, right? You remember how Zn2 plus was getting accumulated, electrons were getting traveled, from the rod to the wire, then to the copper rod. Exactly. So there was a difference, there was a potential difference, which is why the electrons, they traveled from anode to cathode, and that is why electricity was flowing from cathode to anode, isn't it? So that is called as electrode potential. Now cathode has a positive potential with respect to the solution. The anode has a negative potential with respect to the solution. Okay, so electrode potential, when the concentration of all the species involved in this half cell, all of them are unity, that means 1 molar. Temperature is 298 Kelvin and the pressure is 1 atm. That time we denote it as E naught cell. That time it becomes your standard electrode potential. Are we getting it, everybody? Yes, we're getting it. Cool. Okay. Now cell potential, or this cell electromotive force, this cell potential, it is also called as cell EMF. EMF means electromotive force. What is this? It is the potential difference between the 2 electrodes of galvanic cell, which we just saw. What is it? E cathode minus E anode. That's it. Okay. Now let us understand the representation of a cell. How do you represent a cell? For example, let us still take the Daniell cell. Okay. How will you represent it? The representation is made in this way, guys. Representation. And please pay attention, because this is how they write it in the questions. Okay. So Zn solid to Zn was getting converted to 2 plus in aqueous form, right? Here this 2 lines, that means that there's a salt bridge. Now here what is happening is Cu 2 plus was in the aqueous form and that was getting converted to Cu in solid form. This is how you denote or represent a cell. Alright, everybody, getting it? Okay, so electrode potential of half cell can be written as E cell, E right minus E left, or you can write it as E cathode minus E anode. Okay, whatever basically. Cool. Now we come across something that is called as standard hydrogen electrode, SHE. This standard hydrogen electrode, why did we introduce it? We introduced it because that is supposed to be our reference electrode. Why? Because it can behave like a cathode, it can behave like an anode as well. Yes. When it is acting like a cathode half cell, it goes for reduction. When it is acting like an anode half cell, there is oxidation that is happening. Okay. Alright. So you can measure electrode potential of any other metal using this SHE. Okay. Using this standard hydrogen electrode. You getting it? Okay. Alright, everybody. Now moving on. Now let us let us do all the formulas here, because I've given you the starting bit of the chapter, so you get the hang of it. Basically, in this chapter we talk about batteries, we talk about cells, we talk about electrolytic electrolytic solutions, we talk about Faraday's law, we talk about cell potential, we talk about salt bridge, we talk about relation between delta G and E naught cell, because we just spoke about spontaneous and non-spontaneous, isn't it? And delta G is related to spontaneity, non-spontaneity, which we know from thermodynamics. So yes, we have to talk about this. Now, we understand that electrical work is basically the decrease in free energy change, okay? And electrical work done can be written as charge multiplied with potential difference. And we know that delta G is equal to minus NFE cell. And here we come across 1 Faraday, which is charge on 1 mole of electrons. Now, if you have a standard condition, that delta G naught is equal to minus NFE naught cell, okay? Now we come across something that is called as electrochemical series. Now this picture is exactly from your NCERT. Even if you cannot see it, it's okay. You know that fluorine is right on the top, everybody, isn't it? Do you all know that fluorine is right on the top and lithium is right at the bottom, okay? So some of the you don't have to remember the values will be usually given in the question, but please do go through this chart again and again. Find a mnemonic and learn the metals. Which one is what, which one is where, which one is on top of the other one. All of that you must know, okay? Find a mnemonic and please do learn it. This is exactly ditto from your NCERT, so I expect you all to go through this once again, because this is necessary for your board examination as well. But choose, saying it again and again, please do go through the electrochemical series, okay? Then the most important formula from this chapter is your Nernst equation, okay? Nernst equation for thermodynamics, we understand that it is delta G is equal to delta G naught plus RT ln of Q. Now whenever we have natural log, what do? We can convert it into log base 10. That means we will do delta G naught plus 2.303 RT log 10 Q. Now delta G can be written as minus NFE cell. So we are writing here minus NFE is equal to minus NFE naught plus 2.303 RT log 10 Q. So here this means that NF will be cancelled, then we will get here E is equal to E naught minus 2.303 RT divided by NF log Q. That means we have divided NF each and every place, okay? Now we can write E is equal to E naught minus 0.059 N. How did we get to this? See, 2.303 RT and F, all of them, my dear students, are a constant. So the value of constant, when we put all of these and we calculate it, we get it to be 0.059 divided by N, log of Q. Sometimes you can also take it as 0.06, okay? But that will be given in the question, okay? Temperature is 219 Kelvin and capital R value we know it is 8.314 joule per mole per Kelvin, and here N is equal to number of electron in balanced equation, F is equal to 96,500 coulomb, okay? Alright, now if you want to calculate KEQ, KEQ is equilibrium constant. How will you do it? E is equal to E naught minus 0.0591 N log of Q. At equilibrium, Q will become KEQ and E will become 0. So it will become E naught is equal to 0.0591 divided by N log of KEQ. Got it? Yes, these are all the important formulas, guys. Now, Faraday's first law of electrolysis. The formula is W is equal to ZQ. Here Z is mass of substance in grams. Q is charge passed in coulomb. What is that? Z is electrochemical equivalent. That means we can write it as capital E divided by 96,500. What is E now? E, as you can see, it is equivalent weight of the substance, okay? E can be given as molecular weight divided by n factor. That means m divided by nf. And what is n factor? N factor is the number of moles of electron that is transferred for 1 mole of the substance. Okay. So that can be W is equal to E divided by 96500. Q is equal to E divided by 9650500 I multiplied with T. That is your Faraday's first law of electrolysis. Okay. Now Faraday's second law of electrolysis, we come across W by ECU is equal to W by EAG is equal to W by ENI. What does this mean? We are not understanding anything, ma'am. What are you talking about? You are just reading the slide. That is what you're going to say, isn't it? That is what you're going to say, isn't it? Yes? मार खाओगे बच्चों, मार खाओगे, huh? मार खाओगे. What is Faraday's second law? What did he say? What did he say, everybody? He said that the amount of time, okay, the amount of time you allow the electricity to pass through, that is the amount of deposition that will occur. That is the amount of deposition that will occur, isn't it? Yes. So that means that this is exactly what they are trying to say here. See, W by E Cu is equal to W by E Ag is equal to W by E Ni. Okay. Alright. Now finally we come across resistance and conductance here. R is equal to rho divided by L, rho multiplied with La. What is rho? Rho is resistivity or specific resistance. L is length of resistor. And A is the area of cross section. Okay. A is the area of cross section. Right, everybody? Yes, guys. Is there any issues? Is there any issues, everyone? Any doubt? Anything? Yes? Yes? So here once again, everybody, if you did not understand, let me reiterate. Faraday's second law of electrolysis, it states that if the same amount of electricity is passed through different electrolytes, the masses of ions that are deposited at the electrons, they are going to be directly proportional to the chemical equivalence. That is exactly what is written. W by E is chemical equivalence. Do we understand this? Yes, I hope it is all clear. Chalo. Moving on now, come to conductivity. Conductivity is given by kappa is equal to 1 divided by rho, where kappa means conductivity or specific conductance. We can also write it as kappa is equal to capital G multiplied with L divided by A. What is L divided by? It is cell constant. Length divided by area of cross section. That's it. What is unit of kappa? Simon per meter or Simon per centimeter. Okay. And specific conductance is basically conductance multiplied with cell constant. Okay. Now there are different types of conductances, bachos. There are different types of conductances. That is molar conductance, lambda m. How do you calculate lambda m? Lambda m is equal to 1000 multiplied with kappa divided by m. Unit Simon centimeter square per mole. Equivalent conductance. Lambda eq is equal to 1000 multiplied with kappa divided by normality. Can you remember it? Very easy. So now if you want to find a relation between molar conductance and equivalent conductance, what will it be? It is nothing but lambda m divided by z, or you can write it as m divided by n, that means 1 divided by z, and that is why lambda m divided by z. Okay. Now effect of dilution on lambda m and k, please do go through this graph. This graph is very important. For strong electrolyte, if you extrapolate the graph, you will be able to find the limiting molar conductance. But for weak electrolyte, what will happen is it will be parallel to the y-axis. For a strong electrolyte, lambda m is equal to lambda m infinity minus b root over c. What is b root over c? Right here it is written. Lambda m is equal to lambda m infinity minus b root over c. Okay. In this equation, as c increases, lambda m decreases. Okay. And here, this is the equation. This is the equation right here for the straight line. Y is equal to mx plus c. So you correlate and then you try to find the slope and whatever. Okay. Alright. Finally, we are coming to Kohlrausch's law. Law of independent migration of ions. The limiting molar or equivalent conductivity of an electrolyte. It can be represented as the sum of the individual contributions of an ion and cation. That means lambda m is equal to V plus lambda V lambda plus V lambda minus. Basically, if you have let's say a compound Al2SO4 3, then it will be 2 lambda infinity Al plus 3 lambda infinity SO4 2 minus. Okay. All right. Application of Kohlrausch law. Where do you use it? You use it to calculate the conductance of weak electrolytes. We will be doing some problems, so you will understand. Then you also you also use it to calculate degree of dissociation alpha for weak electrolytes, everybody. Then you also use it to calculate the dissociation constant of weak electrolyte. Also, you try to calculate solubility and KSP of sparingly soluble salt with the help of this formula. These formulas, these PDFs, you will get it. Don't worry about it. Now let us solve questions. This is the main important part. This is the fun part of the session. Okay. So guys, everybody ready? Let us try to solve it. Come on. Here, at 298 Kelvin, 1 liter solution containing 10 millimole of Cr2O72 minus and 100 millimole of Cr3 plus shows a pH of 3.0. Given Cr2O72 minus to Cr3 plus, E naught is equal to 1.330 volt and 2.303 RT divided by F is equal to 0.059. The potential for the half cell reaction is given as X multiplied with 10 to the power minus 3 volt. What is the value of X? Okay. So your reaction is given to you. Do we want to write the reaction again? No. Let us try to make our work easier. So we know directly the formula. E is equal to E naught minus 2.303 RT divided by NF log Cr plus 3, because here if we write it, if we actually write the equation, right? If we actually, chalo, let me write the equation just to make it a little bit simpler for you all, okay? So we know that it is Cr2O72 minus, right? This will form here Cr plus 3, correct? Okay. Now here let's say that we will have H2O, okay. Now here it is in plus 6 oxidation state to plus 3 oxidation state, but there are two, but there has to be actually two Cr plus 3. That means that here there are 6 electrons that are getting mismatched. 6 electrons, so here we will have to, 1 H2O here, 14 H plus. This is the reaction. So that means here it will be 7 H2O, right? This is the equation. So here Cr plus 3 and here is the stoichiometric coefficient 2, right? So Cr plus 3 raised to the power 2 divided by everybody, we will have Cr2O72 minus multiplied with H plus concentration, which is raised to the power 14, everybody. Now what do we have to do? Nothing much. We just have to put the formula. Substitute the value. See, E naught value is given to you 1.33 minus 2.303 RT. NF is equal to 0.059. So 0.059 divided by 6. Okay. And then here you have log 0.1 square, because it is given here 10 millimolar and 100 millimolar, right? So 0.1 square, and then we have 10 to the power minus 2 here, and here we will have, 10 to the power minus 3, 298 Kelvin, pH shows 3. Okay, so 10 to the power minus 3 to the power 14. Now if you solve all of it, what will you be getting? What will you be getting? Yes, come on guys, calculate this, just calculate this. I think you will find the answer. Calculate this from here. Shows a pH of 3.0. So yeah, 10 to the power minus 3 to the power 4, 10 to the power minus 2 is also written here. Yes. Yeah, everything is sorted, guys. Come on, calculate this. Tell me. What is the answer? I think some of you saw the answer. Huh? Some of you saw the answer. The actual answer is, it should be 917 into 10 to the power minus 3 volt. Yes, that is the answer. And X value is equal to 917. Chalo. You will also remember. No, I'm giving you chalo. Okay. One, I will forgive it for you. For the next question, I'm not going to show you the answer now. Chalo. Let us do this. Next question is, consider the cell PTSH2 solid 1 atm to H plus. Concentration of H plus is equal to 1. Then there is salt bridge. Fe plus 3, Fe plus 2. PTS given E naught of Fe plus 3 to Fe plus 2 is equal to 0.771 volt, and E naught of H plus to half H2 is equal to 0 volt. So T is equal to 298 Kelvin. If the potential of the cell is 0.712 volt, the ratio of the concentration is what? So basically in this kind of a reaction, you have everything. Anyway, Now let us write what is happening at anode. What is happening at anode? Anode, here you can see that half H2 is forming here H plus, right? H plus aqueous plus electron here. Okay. Now at cathode here, what do you see? At cathode, what is going to happen? Fe plus 3 plus electron, it is forming Fe plus 2. Alright, yes. So now from here, if we want to find the overall reaction, guys, the overall reaction is going to look like half H2 plus Fe plus 3. It forms H plus Fe plus 2. Correct? Yes. Now what is the formula that we are going to use? The formula that we will be using is E cell is equal to E naught cell minus 0.059 divided by 1 log Fe plus 2, whatever is in the product side, okay, multiplied with H plus divided by whatever is in the reactant side, so Fe plus 3. And here, okay, H2 is in gaseous phase, isn't it? Half H2 is in gaseous phase, correct? Half H2 will be in the gaseous phase. So here we cannot take the concentration, we will take pH2 raised to the power half. Cool. Now what are the things that are given to you? See, once again you have seen the answer. Once again you have seen the answer. Chalo, no problem. It's okay. So now what are we going to do is we are going to solve it. Okay. Now we know, first of all, let us calculate. 1 second. Sorry here. Let us calculate the E naught cell. How do you calculate E naught cell? E naught cell is basically E naught cathode minus E naught anode. Yes. Now what is E naught cathode, guys? E naught cathode is going to be 0.771. See, it is given to you. 0.771 minus 0 volt. So minus 0, this is basically 0.771 volt. Correct? Yes, absolutely. Now let us put this value in the formula, in the previous formula, which is basically 0.712 is equal to 0.771 minus 0.059 divided by 1. And then for H plus and H2 plus, let's forget it. We can directly write it as Fe plus 2 divided by Fe plus 3. Okay. Now if you calculate it for this, what will you get? What will you get? What will you get here, everybody? For Fe plus 2 and Fe plus 3. Yes. I think this is going to be equal to 1. No, 1 second. Have I made any mistake in the formula? No, no. Yeah. There has to be log. That's why I forgot. I was like, hurry. Log of this should be 1, isn't it? Log of. So now if you calculate this, okay? So if you calculate all of this, calculate. What do you get? What do you get, guys? You will find that log of, 1 second. Sorry. My mistake here. Log of Fe plus 2 divided by Fe plus 3. Calculate and tell me what is the answer that you are getting. What is the answer that you are getting? Calculate, guys. Quick, everybody. Calculate. What are you guys getting? If you calculate this whole part, you should be getting 1. Then if you take anti-log, then the ratio value will be Fe plus 2 divided by Fe plus 3. That will be equal to 10. So 10 is the answer. That's how 10 is the answer. If some of you are telling me, ma'am, log of this value will be 10, wrong. People, pay a little attention. This is going to be the second attempt, everybody. You cannot mess it up, okay? Chalo, next question, guys. Now here we have PTSH2 gaseous 1 bar, H plus aqueous 1 molar, then salt bridge M3 plus M plus PTS. The E cell for the given cell is 0.1115 V at 298 Kelvin when M plus aqueous divided by M3 plus is equal to 10A. What is the value of A? Acha. So as per this question, you can see that our reaction is going to look like H2 plus M plus 3, and then it will form M plus plus 2H plus. Correct? According to the question, the reaction that is noted here. Now from here, we all know that E cell we have to calculate. See, same formula, guys, same formula. Slightly annoying, isn't it? Same formula, exactly the same formula is what you have to use. So anyway, E cell. Now you can, how did I get to this point, or how did I get to this equation? If you write down the half-half reaction and then find out the overall reaction, this is going to be the overall reaction, okay? Alright. So E cell here is equal to E naught minus 0.059 divided by 2. Then log of, yes, log of, what am I going to write? M plus on the product side divided by M plus 3 in the reactant side. Correct? Okay. Now, what else is given here? Anything else that is given to you? So E cell, E cell, E cell, E cell, E cell is given as 0.115. Okay, 0.1115. E naught value is given to you as 0.2 minus 0.059 divided by 2. So log, now calculate M plus divided by M plus 3. Calculate the value for log. Calculate the value for log M plus log M plus divided by log M plus 3. Calculate it, guys. Calculate it, come on. Come on, come on, come on. What did you get? Did you guys get 3? Yes. So this value, log M plus divided by M plus 3. This is supposed to be 3. If this is 3, then according to the question, log 10A is equal to 3. So that means that A is equal to 3, because 10 will get cancelled, log base 10, log 10, right? This will get cancelled. So the answer is going to be 3, okay? Next question, everybody, is, oh, this question we have repeated way too many times, isn't it? This question we have repeated way too many times, okay. So for the following figure shows dependence of molar conductance of two electrolytes on concentration. Lambda m naught is limiting molar conductivity. The number of incorrect statements from the following is dash. Lambda m naught for electrolyte A is obtained by extrapolation. Yes. Yes. So many times we have done it, still you guys are forgetting. The correct answer is false. No. Option A is false, because you cannot find lambda m naught for electrolyte A. Electrolyte A is weak electrolyte. If you extrapolate it, it will be running parallel to the y-axis. For B, you can extrapolate and find the lambda m naught. Now for electrolyte B versus lambda m naught versus C graph is a straight line with intercept equal to lambda m naught. Yes, that is true. This is true. At infinite dilution, the value of degree of dissociation approaches 0 for electrolyte B. No, it won't be. No, it won't be. This is not at all true. Lambda m naught for any electrolyte A or B can be calculated using lambda naught for individual. Yes, Kohlrausch's law. So this is also true. So how many of these are correct? 2. 2 is the answer. Okay. 2 of these are correct. Alright guys, moving on to the next question now. The equilibrium constant for the reaction Zn plus Sn2 plus forms Zn2 plus Sn is 1.1 multiplied with 10 to the power 20 at 298 Kelvin. Now the magnitude of standard electrode potential of Sn to Sn2 plus if E naught for Zn2 plus to Zn is minus 0.76 volt is dash 10 to the power minus 2 volt, and you have to calculate till nearest integer. Okay, so according to the question, the reaction is Zn plus Sn plus 2. Yes. And it forms Zn2 plus Sn. Correct? What is the formula that we're going to use here? Nah, this time not the same formula. This time we're going to use delta G naught is equal to minus 2.303 RT log KEQ. Okay? But we also know that delta G naught is minus NF E naught cell, correct? And this side can be written as minus 2.303 RT log KEQ, correct? We can write it like this. So that means now what are we going to do is, we're going to write it as, everybody check it out. It will be E naught Zn to Zn2 plus E naught Sn plus 2 to Sn, which is equal to 0.059 divided by 2 log KEQ. Okay. Now these values are given to you, I suppose. See here, yeah, it is given. So for Zn2 plus 2, Zn is given to you as minus 7.6, minus 0.76. But here we have written it as Zn to Zn2 plus, that means it will be 0.76. That means it will be plus, positive it will become, okay? Plus, now E naught Sn plus 2 to Sn. This value we do not know. We have to calculate. So 0.059 divided by 2 log K EQ. Okay. Yes. Now from here we can calculate it as everybody 0.76 plus E naught Sn plus 2 to Sn is equal to 0.059 divided by 2. And what is the log base 10 of KEQ value? Is it given somewhere? 1 into 10 to the power 20, that is given. So that means we will write it as log base 10 here, 10 to the power 20. Correct? Okay. Now we have to calculate it E naught Sn plus 2 to Sn, correct? But we are not done. One more step, guys. 0.76 plus E naught Sn plus 2 to Sn is equal to, if we calculate now, it will be 0.059 multiplied with 20 divided by 2. Yes. So this will get cancelled. And then we can write Sn plus 2 Sn E naught is equal to 0.059. No, not 0.059. It will be, one second, because multiplied with 10, right? So 0.59. Yes, 0.59 minus 0.76. Correct? Because this will go to that side. So that means this is equal to minus 0.17. That means we can write it as 17 into 10 to the power minus 2 volt, and 17 is the correct answer. Have a look, find it out. Is there any discrepancy? If everything is correct, is the calculation correct? Guys, check it out, let me know. Yes, done? Cool? Chalo, alrighty then, alrighty. Next question, everybody, is lead storage battery contains 38% by weight solution of sulfuric acid. The Van 't Hoff factor is 2.67. At this concentration, the temperature in Kelvin at which the solution in the battery will freeze is, okay, this is actually a question that is from solution chapter, but however, because there is lead storage battery, that is why this is added here, okay. So let's calculate. Delta TF is equal to IKF multiplied with molality. So delta TF is equal to, what is I here? 2.67 multiplied with KF value is given to you as 1.8, okay. Then what are you going to do? 38 is given to you. So 38 divided by sulfuric acid. What is the molar mass? 98 multiplied with 1000 divided by 100 minus 38 is 62. So let's write 62 here. Now calculate, everybody. Calculate what is the delta TF value. Calculate. I'll tell you in some time. Calculate. Come on, quick. If you calculate this, how much will you get? How much will you get, guys? Whatever value you get, after that you have to find the freezing point. Yes. After that, you have to find the freezing point, everybody. So tell me these two values. I am gonna let you do this. Okay, you can tell me the value in the comment section after the class is over. I'll wait for your comment section. Okay. Chalo, guys. Moving on to the next question here. Let us go to the next question, everybody. Let us solve this and let us read the question, everybody. The electrode potential of the following half cell at 298 Kelvin is x2 plus 0.001 molar, salt bridge y2 plus to y 0.01 molar is dash 10 to the power minus 2 volt. Okay. So we have to calculate this, everybody. What is the reaction? The reaction is X plus Y 2 plus, alright, and this is forming Y plus X 2 plus, correct? Now once again we will use the same formula, that is E naught cell is equal to, this time however we have 0.06 volt, just the value has changed, so we know that it is E cell, that is 0.36 minus, yes, minus 2.36, which is equal to 2.72 volt, right? That is going to be our E naught cell. Now we have to calculate E cell, which is going to be 2.72 minus 0.06 divided by 2, and then we will use log 0.001 divided by 0.01. Calculate. You just have to calculate here. That's it. Nothing else. Nothing else. What will you get here? 2.72 minus 0.03. This is equal to 2.75 volt. That means you can write it as 275 into 10 to the power minus 2 volt. So your answer is 275. Cool. Alright. Yes. The question says logarithm of equilibrium constant for the reaction PD2 plus 4Cl minus gives PdCl4 2 minus is dash. Okay, the log of equilibrium constant, basically that's all that we have to find out. Okay, the log of what? The log of equilibrium constant. Sorry, I was lost. Yes, okay. So now here, what is given to you? What is given to you? That 2.303 RT by F is equal to 0.06. Okay. Then what is given to you? E naught is equal to 0.83 is given to you. Okay. The equations are also given to you. E naught is equal to 0.65 volt. That is also given to you. Okay. So we all know that delta G naught is equal to minus RT ln of K, isn't it? Yes. Now we can write delta G naught to be minus NF E naught cell. Yes. This is equal to minus RT multiplied with 2.303 log base 10 K. Yes, this is the same formula that we're going to use. So now we can write E naught cell divided by what do we know? Divided by 2.303 divided by, so E naught cell here and 2.303 divided by F is equal to 0.06. So 0.06 multiplied with N is equal to log K. Let us call this equation 1. Okay. Alright. Now let us come to this side and we will do the other half, rest half of the solution. So here you have PD plus 2 aqueous plus 2 electron, which forms here PD solid. This is the equation, right? This is the equation that I've written it down. And here the E naught for reduction, this is the reduction, guys. So E naught for reduction is also given to you, 0.83. In the next one here this is for E naught anode, that is oxidation, that is also given to you. Alright. So our overall reaction is going to be, I'm going to erase this and I'm going to directly write the overall reaction because we have this two reaction here. Yes. Overall reaction, everyone, is, if you look at it, one second. Overall reaction, yes. PD plus 2, yes, plus 4Cl minus. This will give you PdCl4 2 minus. Correct? Now from here we can find the E naught cell. So E naught cell is going to be equal to E naught cathode minus E naught anode. Correct? That means this is equal to 0.83 minus 0.65. Okay. So if you calculate it, this will be 13 minus 5 and 0.18. This is 0.18. Yes. And here we see that there are two electrons. So the give and take, the relationship of give and take is happening via two electrons. So that means N is equal to 2 here. Now we want to calculate E naught cell divided by 0.06 multiplied with 2 because N is equal to 2. This is equal to log of K. And E naught cell is also something that we have calculated, which is 0.18. 0.18. So 0.18 divided by 0.06 multiplied with 2, that is equal to log k. If we calculate it here, we will find that log k value is equal to 6, and this is exactly what we had to figure it out. Is that not? This is exactly what we had to figure it out, isn't it? Yes or no, guys? Come on, quickly answer. 0.18 divided by 0.06 is equal to 3, right? And this multiplied with 2 is equal to 6. So that is your answer. Very, very good. Very, very good, everybody. Well done. Chalo. Now let us go to the next question. And the next question, everybody, is the resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 to the power minus 3 ohm centimeter. Its molar conductivity is dash into 10 to the power 4 omega to the power minus 1 centimeter square mole to the power minus 1. Okay, so how do we calculate this? Lambda m is equal to kappa multiplied with 1000 divided by capital N. But we also know that lambda m is equal to 1 divided by rho is multiplied with 1000 divided by m. As per the value that is given, we know that 1 by rho, right? See, the resistivity is given. So that means it is 1 divided by 5 into 10 to the power minus 3 multiplied with 1000 divided by 0.8. Calculate. Calculate and tell me the answer. Calculate and tell me the answer. What is this? I have given you all the formula and everything. Now you just have to tell me the answer. Alright guys, now we are moving towards chemical kinetics. So what do we do in chemical kinetics, guys? What is it that we do in chemical kinetics? Now chemical kinetics, this is the chapter. In this chapter, the rate, velocity or speed of reaction is studied, okay? Now we all know that feasibility of reaction was given by thermodynamics, that delta G naught if it is greater than 0, it is going to be non-spontaneous. Delta G naught if it is lesser than 0, it is going to be spontaneous. Delta G if it is equal to 0, that means it is going to be equilibrium. Yes, so but thermodynamics could not tell us the extent. I mean, it could tell us the extent to which the reaction can happen, but the speed of reaction, the rate of reaction, that is something that thermodynamics could not speak to us at all. Now in this chemical kinetics chapter, we initially start with average and instantaneous speed, but I am not going to get there because average and instantaneous speed is super basic, and you all have studied this in 9th and 10th standard also. Yes or no, guys? Average speed, instantaneous speed, you know that, isn't it? Great. Okay. So now we get to the direct formula, everybody, because that is exactly what we're going to use, everyone, right? So first of all, the first things first, everyone, let us talk about the rate of chemical reaction. The rate of chemical reaction is given as delta C divided by delta T, which is equal to mole per liter divided by second. Or the unit can be mole, liter to the power minus 1, time to the power minus 1, or you can write it as mole dm to the power minus 3, time to the power minus 1. Type of rates of chemical reaction. For a reaction R2P, average rate is given as total change in concentration divided by total time taken. And instantaneous R is given to you as dC by dt is equal to minus dr by dt is equal to dp by dt. Why are we using the negative sign here? Because reactants, they reduce as the time passes by. The reactants, they reduce in concentration. The concentration of product increases. Then we come across zero order reaction. Yes, where rate is equal to K multiplied with concentration to raised to the power 0. Here K is equal to C naught minus Ct divided by T, right? Unit of K is mole, liter to the power minus 1, second to the power minus 1. This you must remember. This unit is very important. They may ask you questions related to this. Then we come across first order reaction. Here T is equal to 2.303 K divided by K log A divided by A minus X, or K is equal to 2.303 divided by T log C naught divided by C. Okay. If you want to calculate average T, then it is, or if you want to calculate half-life, T half is equal to ln of 2 divided by K, which is equal to 0.693 divided by K, independent of initial concentration. Yes, T half is independent of initial concentration. T average is equal to 1 divided by K, which is equal to 1.44 T half. Then here these are the graphical representation. Do look at the graph. You will be getting this PDF. Hence, I'm just fastening it up a little bit because we also do not have so much time. We have to solve question. Now, for the nth order of reaction, okay, A to product, what will happen? T half is given to you as 1 divided by K multiplied with n minus 1 multiplied with 2n to the power minus 1 divided by A to the power n minus 1. This is the formula. As we solve the question, it will be all clearer to you. Now we come across Arrhenius equation where K is equal to AE to the power minus EA by RT. Here K1 and K2 are the rate constant of a reaction or of two different temperatures of T1 and T2. And if that is the case, then it will be log K2 divided by K1 is equal to EA divided by 2.303 R 1 by T1 minus 1 by T2. Okay. This is the graphical representation here. Now, let us start with our question, guys. I think we should start with the question because the questions are the only thing that can actually allow us to understand how to solve the question. So how to solve questions actually in our paper. Anyway, so for a first order reaction, the time required for completion of 90% reaction is X times the half-life of the reaction. The value of X is what? You have just studied, isn't it? You have just studied, right? So here, what is happening, guys? Here, what is happening? Everybody. What does the question say? The question says that everybody, something is wrong with my laptop, guys. I think it has become very hot. So we have to quickly finish, everybody. Quickly, we have to cover it up, okay? Yeah, it has started to flash. It might just get switched off. Very sorry. Quickly, let us do this quickly, okay? Yeah, it's definitely not working fine. Chalo. A is forming here products, okay? A is forming products here. Now for a first order reaction, you all know that T half is equal to ln of 2 divided by K, or directly, why even write this, okay? Directly we can write it as 0.693 divided by K, okay? Now the time for 90% conversion, everybody, is, okay? The time for 90% conversion, okay, how will you write it? T 90% is equal to 1 divided by K ln of 100 divided by 100, because in the question it is written 90%. So total completion is 100. Now 100 minus 90 is what? 10. Exactly. So now we will write it as ln of 10 divided by K is equal to 2.303 divided by K. Yes, right, everybody? Now if we want to calculate further, so T 90% is equal to 2.303 divided by, what is the value of K here? No, we will write it as 0.693 multiplied with T half. Yes, if you calculate this, now calculate this, what will you get? Now if you calculate this, I think 2.303 divided by 0.693 is equal to 3.32. 3.32 T half, isn't it? Yes, so that means it has to be option C. That is your correct answer. Option C is your correct answer. Alright, everybody. Moving on to the next question then. Here, what do you have? For a chemical reaction, A plus B forms product. The order is 1 with respect to A and B. Now here they are saying that rate is given to you, A is given to you, B is given to you. Okay. So if that is given to you, that means we can write it as R is equal to K, A to the power 1 and B to the power 1. Yes. Now initially what is given to you is 0.1, rate is given to you as 0.1, which is K, then 20 to the power 1 and then 0.5 to the power 1. This is your equation 1. Then you can write it as 0.40 is K multiplied with x to the power 1, and here it is written as 0.5 to the power 1. That's your equation 2. Finally, the last one here, if you write it down, 0.80 is equal to K multiplied with 40 and then y to the power 1. Let's call this equation 3. Now from equation 1 and equation 2, I think we can calculate x here, can't we? We can calculate x here, right? 0.1 here, 0.40. So 20 here and then 40 here. So that means that x is going to be equal to 80. right? And then from equation 1 and equation 3 here, we can calculate how much is going to be y. This is 0.5 and this is nothing here. This is 40 here. This is 80. 0.80, 40 and here it is 0.1. That means that I guess y is equal to 2. Yes, y is equal to 2. Calculate this and find out. So yes, the correct answer, my dear student, is option C. Okay? Alright. Moving on to the next question, everybody, is at 30 degrees Celsius, the half life for the decomposition of AB2 is 200 seconds and it is independent of the initial concentration of AB2. Hence, what is going to happen? The time required for 80% of the AB2 to decompose. Achha, now they're saying that it is independent of the initial concentration and we know that only happens in first order reaction. So that means that Ke is equal to 2.303 log 2 divided by T half. Okay. So that means now I can also write it as 2.303 log 2 divided by T half is equal to 2.303 divided by T. Achha, I don't have space enough, yeah. Do not have space enough. Let me write this down here, okay? I'll write this down here, okay? Array, sorry guys. 2.303 log 2 T half is equal to 2.303 divided by T log 100 divided by 100 minus 80. Can we write like this? Yes? We can write it like this, everybody? Yes or no, guys? Yes? Okay. Now log 2 value is given to you 0.3. So that means 2.303 multiplied with 0.3 divided by T half is 200 seconds. So 200 is equal to 2.303 divided by T. T we do not know. And log 100 by 20. That means log 5. Log 5 we can write. Now from here, if you try to calculate T, how much will you be getting, guys? How much will you be getting? You have to calculate T. Can you calculate and tell me? So you just have to calculate. Yes, you can calculate it here. You are given log 2 value, log 3 value is given to you. Just calculate, you will find it out. Okay. Solve this. Next question. The next question, everybody, is the number of correct statements from the following is: larger the activation energy, smaller is the value of the rate constant. Yeah. I mean, what is the equation? Isn't it K is equal to A e to the power minus EA divided by RT? Yes. So if EA increases, that means K decreases. So this is true. This is true. Now for B, let's solve for B. The higher is the activation energy, higher is the value of the temperature coefficient. Okay, for B also let's solve it. See, we can write it as ln of K is equal to ln of A minus EA divided by RT. That means we can also write it as 1 by K multiplied with dk divided by dt, which is equal to EA by RT square. So if EA increases, then what will happen to the temperature? The TC, if EA increases, then TC will also increase. Temperature coefficient also increases. So this is also true. This is also true. At lower temperature, increase in temperature causes more change in the value of K than at higher temperature. No. If you draw the graph, guys, this is your T, this is your K, and the graph goes somewhat like this, right? So no. From the graph itself, you can tell that this is false. Fourthly, a plot of ln of K versus 1 by T is a straight line with slope equal to minus EA by RT. I mean, obviously, look at this. ln of K is equal to ln of A minus EA by RT. So if you just want to correlate y is equal to mx plus c, then m is equal to what? M is equal to minus EA by R, isn't it? So yes, option D is also correct. That means that only option C is false. The number of correct statement here is 3. That is the correct answer. Okay, that is the correct answer. Chalo guys, next question, everybody, is for the first order reaction A to B, the half-life is 30, half-life is 30 minutes, I guess. Here it should be 30 minutes, right? Now the completion of the reaction is dash millimeter. They are writing. I think it should still be minutes. There should be some error, typing error. Now the time taken for 75% completion of the reaction is how much? Okay, there is a trick, guys. This is a trick. And the trick is that T 75% is equal to 2 multiplied with T half. So you can easily calculate it, and 2 into 30 is going to give you 60 minutes. So that is the correct answer. This is a trick. T 75% is equal to twice of half life. Okay, that is the correct answer. Chalo guys, moving on to the next question here. The next question here is, will you all be able to do this? Will you all be able to do this, guys? I think that I am a little too tired. So now here there are few more questions. There are few more questions which I want to give it to you as a homework. Yeah, I want to give it to you as a homework. So yes guys, as I was telling, I think I'm going to give it to you as a homework because my laptop is also not working much better. It is almost about to get switched off and it is blinking, and I'm not able to see myself, so I don't know when and at what time it is going to get switched off. Right now it just went off again. So I think guys, it's better if we just solve it on our own. Yes, and these are the this PDF you will get it in the Telegram channel. So be sure that you solve the question because it will definitely benefit you, everybody. And with this note, tata, bye bye. I'll see you guys very soon, and lots of love. Also, I really need rest. My throat is paining like anything. So see you guys later. Bye bye.